Hi everyone. I think it's time for another post-processing effect that we can apply to the entire screen or a selected element. This time, we'll recreate the look of an old photograph that has yellowed over time and develop other signs of wear. So, let's get started. So, just like almost every time, I'll create a new scene, drop in the usual image from our game, Whispers of Prague, and apply a shader to it. So right-clicking the Themes folder, create a new scene. It's supposed to be a 2D scene, and let's call it old photo. Okay, now I'm dragging the image found in JPEG into the 2D editor. So the sprite 2D node was automatically created. And let's do the usual stuff in the inspector, expanding offset and canceling centered. Then expanding transform and resetting position to 0, 0. Okay, now I'm scrolling down to the material section and adding a new shader material to the material property, clicking it, and let's add a new shader, which is type shader, mode canvas item, and the path will be shader/oldphoto.gd shader. Create and click again to open it in the shader editor. Let me just fix the width. Okay. So as before, we'll start by deleting what we don't need in this tutorial so that only the fragment function remains. Let me expand this window and I'm deleting vertex and I'm deleting the white function. Ctrl S to save. Alright, so this shader is quite specific because it modifies the image on multiple levels, which requires a considerate number of parameters, in this case 13. Since the shader code itself will also be a bit longer than usual, I'll try to save time whenever possible. So I'll insert all 13 parameters directly into the code and then briefly describe them. Okay, let me expand this window and I'll paste the uniform parameters right here. And here we go. So the age is probably self-explanatory. 0 means the original image, 1 represents complete wear, and adjusting this parameter can simulate the gradual aging of a photograph. Then the parameters sepia strength and yellowing determine how much the original color fade and how much the paper turns yellow. Their combination also affects the enhancement of bright areas and the suppression of darker ones. As for vignette strength and sharpness, these control the typical darkening of the edges of a photograph, which emphasizes with emphasis on the corners. The parameter wrinkle amount and the wrinkle scale are responsible for simulating wrinkled paper, which means an image deformation near the edges. Using the next two parameters, spot density and spot strength, we define pseudorandom stains on the surface of the photo. The grain strength parameter controls the characteristic paper texture of the final effect, and with the fade parameter, we can adjust how much the image has faded, of course. Finally, seed serves as the basis for the pseudorandom vector generator, allowing us to change the shape, size, and distribution of the spots. Okay, so those are the parameters, and next we proceed by adding functions related to generating pseudorandom values. Once again, I copied them from another of my tutorials. Okay, and let's do it right after the uniform parameters, pasting. The first one, hash12, represents simple digital noise, and the second one, the noise, generates a grid with smooth transitions between individual cells. Now I'll write another function. It will be a simple application of the previous functions, these two ones. within the fractal Brownian motion algorithm, which we already know from previous tutorials. If not, I am including a link again to the excellent resource, the Book of Shaders, where you can learn absolutely everything about this function. So let's write it here. Float FBM with the input parameter vec2b for a point in a 2D space. And now float v starts at 0, float a starts at 0.5. This is just basically the algorithm I always use, and it represents values like amplitude, frequency, and their changes. I think it's probably necessary to explain every line in details. Sometimes I'm using arbitrary numbers, which are results of my previous experiments. And now the cycle for int I from 0 I to 3 I plus plus. Okay, as you can see, I am using a fixed number of iterations this time because it's definitely not necessary to overdo it. We just want stains which look somehow discrete. So yeah, this should be fine. And P equals P times 2.1 plus S age, and A is multiplied by 0.5. And finally, I'll return the value V. So in case there are issues rewriting this code from the video, just remember that the whole source code will be included in the Godot shader pack, which I link to in the video description. Okay, we can continue. I'll write one more function that will allow us to create a so-called sepia-toned color image, which is typical for old photographs. Writing right here, vec3, let's call it 2sepia, and the input parameter is simply float luminance of the pixel, because we are supposed to turn the image into a grayscale sorry grayscale version and then apply this kind of effect. So this is a well-known algorithm using two vectors. Let's call it sepia high, which is a vector 3 and with values 1, 0.89 and 0.7. This one will just will create warm highlights. And now for the low end, sepia low is vector 3, 0.35, 0.25, 0.15. And this is supposed to make the shadows darker. All right, and let's return the mix based on the luminance. So return mix of sepia low, sepia high, and luminance is the weight factor. Perfect. Okay, so let's move on to the fragment function. In this function, I'll apply the individual filters and transformations, which I'll split into separate functions to keep the code more readable. This time, we are not creating any symmetrical effect, nor do we need to recalculate the aspect ratio, so the first line will be very simple. So I'm deleting this comment and writing vec2 uv equals simply internal uv vector. For several of the following operations, it will be useful to know the distance of the current pixel from the nearest edge. We can easily compute that using a combination of min functions. So let's do it here. Float edge dist is minimum of uvx and 1 minus uvx, both edges horizontally and vertically, minimum of uv dot y and 1 minus uv dot y. Okay, now I'll turn this value into a mask using a smooth step function, our usual trick. Float edge mask equals 1 minus smooth step of 0 and again an arbitrary edge, the result of experiments, edge dist. Okay. Perfect. And again, we are subtracting the smooth step from 1, so we will be working with the real edge, not the inside of this structure. Okay, and now let's implement the effects. First, I'll add a deformation of the UV coordinates near the edges. I think it's time to show the image again and more of it. So the edges we'll be working with. For which we can use this mask. So let's add a new function above the fragment function, scrolling up. So where is it? To sepia fragment, it starts here. So let's do it right above that. Void add edge wrinkling. Okay, and the parameters in out vec2 UV float edge mask. I'll just write it first and then briefly explain that. So vec2 wrinkle UV is UV times wrinkle scale, our parameter, plus seed, another parameter. So we are creating deformed coordinates right now, and now let's apply it to create a distortion vector. Vec2 distortion is vec2, and let's put it to normal brackets, 2 lines to make it better readable. FBM function applied on wrinkle UV plus, and again some vector looking pretty random. You can of course use other numbers to experiment with that. And the second line will be basically the same, just with another shift. So it's the same, and the vector this time I think I used 8.3 and 2.8. Okay, and let's multiply the result by 2 and subtract 1 to remap it to a new range. All right, and now let's apply it to the original UV vector. UV is increased by this distortion times wrinkle amount times 0.1, because the amount is too high, so we are dividing it by 10, times edge mask, just to use it only in the edges, and times age. So it is also influenced by the expected age of the photograph. And finally, let's clamp it, because the UV coordinates could have exceeded the 0 to 1 range. Let's fix that. 0 and 1. Okay, so what did I do here? It's the result of various experiments as usual. So I'll just very briefly explain that we deform the coordinates based on the chosen parameters and the pseudo-random factor, which results in a fairly convincing wrinkled paper effect along the edges. In addition, we also use the H parameter, as I said, so the level of deformation increases as its value grows. Also notice that I use the in-out modifier for the UV parameter. This means it acts as both an input and output parameter. So when we call this function from the fragment function, the UV vector will be modified after the execution, the function executes. Like this. Let's scroll down to the fragment function and add it as the last line. Add edge wrinkling with parameters UV and edge mask. Okay, perfect. And so we can finally see some change. I'll add lines to sample the pixel, add the modified UV coordinates, and display it. Vec3 color is the function texture applied on our texture and modified UV coordinates, and since it's vector 4, let's use only the RGB components to turn it to a vector 3, and finally let's assign it to the output internal variable color, which is vector 4 consisting of color and 1 for alpha. Okay. So now if I zoom in on the edge, like here, we can definitely see some level of distortion, some deformation. If I now change the edge parameter in the inspector, decreasing and increasing, we can observe it in the image as well. Likewise, we can fine-tune the level of distortion using the wrinkle amount and the wrinkle scale parameters. Yeah, definitely there are many ways to simulate this kind of effect. Okay, let's zoom out. All right, so the deformation is done. And now we'll move on to modifying the color of the current pixel. This means the following functions will use the in-out modifier for the color parameter, which represents the color in RGB format. So first, I'll apply an enhanced sepia effect. Okay, and let's expand the window again so we can see the whole code here. And I'm adding a new function, void add sepia tint with parameters vec2 UV, current pixel, and as I said, in-out vec3 color. All right, so let's start. I think I'll just paste the first line because it uses specific parameters to create a luminance of the current pixel, effectively turning to a grayscale. I don't want to do any typos here. All right, now that we have the grayscale value, we want to lift shadows slightly because the aged paper never turns true black. It is always brownish a little bit. So let's do it right here. Grayscale is grayscale times 0.88 plus 0.06. Okay, now it's time to apply the 2sepia function we created before. Vec3 sepia is 2sepia of our new grayscale value. Okay, very well. Let's add some extra yellow push on the bright areas. So I'll create a vector 3, which I call yellow tint. And it's simply a kind of a yellowish color with these RGB values, 1.95 and 0.65. Okay, and let's mix it into the sepia vector. Is mix sepia times yellow tint and yellowing parameter times our grayscale value. All right, and finally, let's mix it into the existing color. So color is mix of color, sepia, and sepia strength times age for the weight factor. All right, it's finished, and we can add it to the fragment function, and I think it should be after this line because we are already using the color. Let's get back so we can see the image and add sepia tint with parameters UV and color. Okay, wait for it. Here we go. That already looks more interesting. Next, we'll apply the fade parameter for overall photo fading. Since it's just a single line of code, I'll simply write it directly into the fragment function right here. So color is again a mix of previous color and the this kind of effect is a combination of the color and the white color, and the weight factor fade times age. Okay, yeah, this photo now looks noticeably faded, and by adjusting the parameter we can increase or decrease this effect. Yeah, more white, less white. Yeah, I think it's pretty fine. Alright, the next function will add dark spots to enhance the sense of age. Okay, and since this function uses a big number of numbers, I'll better just paste it here and explain the lines, because that's definitely better than to spend more time writing it and doing possible errors. Okay, here it is. So it's just above the fragment function. It's called add spots, and again vector uv is the input parameter and inout parameter vector3 color. So we start with scattering dark brownish blotches using layer noise at multiple scales. As you can see, we have 3 scales right here with different parameters, and all of them are added to the spot noise accumulator. Then we definitely don't want to be that as some kind of smooth map, because the spots should be more discrete. So we create a threshold using the smooth step function to isolate them. And finally, let's improve their color, something like a dark amber brown. And this is the result. As usual, we mix it into the existing color of the pixel and use our parameters, including the age, as the weight factor. All right, let's get back to the fragment function, and let's show the image again. I'm scrolling down and adding it as a new line. Add spots, yeah, and the parameters again, UV and color. Wait for it, and here we go. I think I can show the whole picture. Okay, and if we work with the seed parameter, we can see how the spots change. It's pretty cool. Okay, I think I revert to the original value, and of course, decreasing age decreases everything, because all these functions depend on the age value. Okay, next we'll add a vignette effect, resembling darkened, slightly burnt edges. And again, I think I'll just save some time and paste it here and explain. So I'm expanding the shader editor again, and let's find the fragment function. Here it is, and before that, pasting the function called add vignette with the usual parameters vec2 uv and inout vec3 color. So we are working with the edges, which means we are using a simple remapping to the range from -1 to 1, and then using the dot function to measure the distance. Is actually distance to the power of 2, but it doesn't matter in this case. And this is just to create an elliptical shape, and because we want to add some extra darkening on straight edges so it looks more natural, this is the calculation to achieve that. And finally, we are applying the vignette, clamping it so it doesn't exceed the 0 to 1 range, and mixing it into the previous color, and again making it a bit brownish so it doesn't look like it would be pure black, which is not natural. Very well, and let's get back to the fragment function and show the image and apply it. So another line, add vignette with the usual parameters UV and color. It's pretty simple and useful. And here we go. All right, and we will further refine the edges to make them more pronounced even between the corners. So I'll add one more function and I will again paste it. So let's expand the window, and after add vignette, I'll adding the function called add corner darkness. And this time we have the usual parameters, vec2 UV, in out vec3 color, and also the edge distance, because we'll be working with edges and we need this value. So I'll simply calculate the something like the noise in corners to make it look like more aged. And again, we are using the FBM function to give it some pseudo-random look and feel. And finally, we are incorporating this change into the previous color. And again, using the age parameter to make it dependent on that. And let's get back to the fragment function. Let's show the whole image, and I will add a new line calling this function. So it's add corner darkness, UV, color, and edge this, and semicolon. Okay, yeah, I think you've noticed the change. And as the final effect, we'll add a grain pattern to simulate the texture of paper. And I think this time I can just write it out. It's not too long, so let's add it here. Void add paper grain vec2 UV in out vec3 color, usual parameters. And what do we want to do here? So let's first define the grain using our hash12 function. So the grain is hash12 UV plus seed. Okay. And now I will remap, because the hash12 function returns values from 0 to 1. Let's remap it to -1 to 1. Grain equals 2 times grain minus 1. All right, and finally, as I said, it's very simple. We just apply it to our color. Color is increased by grain times grain strength, and it's too big, I guess, so times 0.1, and again times age. Okay, so this time we are simply adding another layer. We are not modifying the color itself. That's why we don't use mix like here, but we simply add it to the color accumulator. Okay, let's get back to the fragment function and show the image and add the line that calls this function. Yeah, here. Add paper grain UV color. Okay, and here it goes. We are done. I'm not entirely sure how the grain will look after YouTube video compression, but on my screen I can see a very convincing result. Let's just increase the zoom factor. Yeah, hopefully you can see something here. And if I change the grain strength, now it's gone. Now it's the maximum. All right. And of course, we can also tweak everything again. All details we like to create a final look. So let's, for instance, increase the spot strength. Now it's very spotty. Now it's almost invisible. And the density, we can work with that as well. This is pretty cool. Okay. I think that could be everything I wanted to show with this effect. Thank you very much for watching. I hope I didn't overdo it this time with the length and complexity of the code, but some effects simply require a slightly different approach. In any case, if we want to create, for example, photos from the past in our game and then display them on a notice board in the protagonist's home in the future, something like this could be quite useful. And once again, the full shader is available in the Godot shader pack, which I've linked in the video description. For now, take care, best luck with your projects, and I'll see you in the next video.